All right, so welcome back everyone. Today in this video, we're going to be looking and starting transportation engineering. And we're going to be focusing specifically on geometric design. And so I have a few practice problems for you all. So let's dive right in. All right, so number one says, a highway has a horizontal curve with a radius of 700 and a side friction factor of 0.1. Calculate the super elevation rate required for a design speed of 60 miles per hour. All right, so how do we attack each problem? Right? Well, we first have to decide what we're given. So it looks like we are given the radius, which is 700. We're given the side friction factor, which is 0.1. And we're also given speed, which is 60 miles per hour. Okay. What are we trying to find? We're trying to find super elevation. Can we use a formula for this? Well, the first thing I would do is search super elevation in my FE handbook. So two things come up, and the first one shows what super elevation stands for. So it looks like it's a E, or it's represented by the variable E, and it's a percentage. All right, so in the handbook it says the side friction factor based on super elevation. So for this particular problem, we need F, which is side friction factor. We need V, which is design speed. So it looks like we have a side friction factor already, which is 0.1. We have the speed, and then R, which is radius. So it looks like we have all the various variables we need to solve for this problem. So we're going to be using this formula that I highlighted to the right. I'll zoom in a little bit so you all are able to see it a bit better. Okay. So it's going to be 0.01 E plus F, which is what? 0.1, right? It's a side friction factor, and that's equal to 60 squared over 15 times 700. All right, once I put that into my calculator, you should get your E. I'll just do this out. So it was 60 squared divided by 15 times 700. I get is equal to 0.34 minus 0.1 divide that by 0.01, and so I get my E is equal to 24.3%. Okay, so I get B for my answer. All right, so number one says, what is the primary role of moisture content in influencing subgrade performance in pavement design? All right, so when we think of subgrade and when we think of pavement design, you have, I just want to give you a visual of what this kind of looks like. All right, so my blue is going to be my asphalt. And this is why I said prior knowledge is pretty key, because they're not really giving you this information. And then you're going to have subgrade. And the subgrade normally, depending on, what different types of soils you have, you may have two different types of, soils, and that's in red, right? And that's your subgrade. The blue is the asphalt. The subgrade is anything below that is soils, right? So let's start out by going through our given find formulas sequence. So what are we given? We're given, a question. We're not given any variables or anything. So this is kind of like not applicable. What are we trying to find? Well, we're trying to find the primary role moisture content of subgrade performance. Are there any formulas needed? In this case, not applicable. All right, so what's our answer? So A, the moisture content determines the soil type. No, I don't think that's the case. What about B? Moisture content affects the volume change characteristics of soil. So I know from geotech that actually is in fact true. Moisture content directly determines subgrade strength. Subgrade strength is a number of factors. It's not just the moisture content. It's also like things like compaction. There's a few different things that determine your subgrade strength. So I would say no to that. So nope. Moisture content has no significant impact on pavement design. I believe that it does. So just from picking answers, I'm gonna go with B. And I wanted to point out a few other things that is important when it comes to subgrade and how moisture content affects, things. So moisture content does have some impact. Moisture content affects the volume change characteristics of soil. So when you have high moisture, it can lead to swelling in expansive soils, and low moisture can result in soil shrinkage, right? Also, things to think about is excessive moisture can weaken the subgrade, causing like instability and settlement issues. And then proper drainage measures are necessary to maintain moisture levels and prevent, detrimental effects on your pavement performance. So just some extra things to kind of keep in mind if you're given some conceptual questions on this exam when it comes to pavement systems design. I hope that you're enjoying this video. I just wanted to drop in and say, if you're looking to pass your Civil FE exam within the next 90 days, then you definitely want to check out the course that I've created. The video that you're currently watching gives you just a glimpse of what is in the course, and I have made it test taker proof. And what that means is no matter if you've been out of school for a while or you just have trouble with some of the engineering concepts, if you study this material that is in the course, it will help you to pass within the next 90 days. There are also full practice exams. Yes, 110 question practice exams, along with review guides and study schedule templates to help you pass. And these are resources that I have created for you. So if you want to check out any of those, just head down in the description box below and check them out now. Now, to stay up to date on any new videos that I drop, whether it is more practice problems like in this video, or if you want advice and some extra tips to help you pass your Civil FE exam, you're gonna wanna make sure that you hit that subscribe button, turn on those bell notifications so that you know exactly when I post. So let's look at number 1. It says, for a highway segment, the free flow speed is 60 miles per hour and the jam density is 160 vehicles per mile. Calculate the speed using the Green Shields model when the density is 80 vehicles per mile. All right, so we want to start by saying or looking at what we're given. All right, so what is the information that we're given? Well, we know free flow speed is 60 miles per hour. We know that we have a jam density, and that is 160 vehicles per mile. And we know that the regular density is 80 vehicles per mile. All right. So that's all the information that we're given. And what are we trying to find? All right. Well, we're trying to find the speed. And we want to use Green Shields model. All right, so let's do a search, right? Because I'm thinking we're probably gonna need some formulas from the FE manual. So I'm just gonna do a search in the FE manual for Green Shield. If I can spell Green Shields. I search, there's only 2 things that come up in the FE manual, and look at here. So, all right, so traffic flow relationships. And so based off the given information, we're looking for speed. Speed is, according to this, S. All right. So the formulas that I see that we can use is this top formula, S equals, and I'll zoom in so you all can see a little bit better. So S equals SF minus SF over DJ times D. So so basically now we just want to check to see if we have the variables that we need so that we can find the value that we need, right? So what is SF? The theoretical speed or free flow speed, right? We have SF, that is our 60, okay? And then DJ, DJ stands for jam density. We have that. And what about our other variable, which is D, which is the regular density that is in vehicles per mile. So we have everything that we need to solve this. So let's go ahead and solve it out. So S is equal to SF minus SF F over dj times d. All right. S is equal to 60 minus 60 over 160. I'm just plugging and chugging times 80. All right. So once you go through that, you should get S to equal 30 miles per hour, or C. For number 1, it says, given the following information for traffic signal timing, determine the length of a yellow interval to the nearest second. Okay, so we have driver reaction time 2.5. Vehicle approach speed is 20 feet per second. Deacceleration is 11 feet per second squared, and our percent grade is 8% upgrade. They're going up. Okay, so this is good information for us. Let's write out what we're given. Well, it kind of shows us what we're given. So we're given, first thing is a driver reaction time. We're also given vehicle approach speed, given deceleration, and percent grade. Okay, what are we trying to find? We're trying to find the length of a yellow interval. I'm just going to erase that because that is atrocious. Okay, so what are the formulas that we need? All right, so traffic signal timing. I'm just going to search in my FE handbook signal and see what comes up. All right, so 53 things come up. So I'll do traffic signal. All right, only 2 things come up. Cool. Traffic signal timing. All right. All right, so do we see anything for length of yellow interval? Okay, so y, it's like y is equal to the length of yellow interval, the nearest second. Cool. So we have y, or we're looking for y. That's what we're trying to find. Do we have t? So t is the driver reaction time. We have the driver reaction time. Next, we check for v. Do we have v? Vehicle approach speed. We have the vehicle approach speed. What about a? A is deceleration. We have deceleration, and then do we have g? G is the percent grade, and it's plus or minus. So plus would be upgrade, minus would be downgrade. In our case, it's going to be a plus because it is upgrade, or positive grade. All right, so we have all the variables that we need. Now it's just time to solve and plug and chug. So you have the formula there. So I'm just going to start plugging. Hopefully you can follow with me. So y is equal to t, which is 2.5 plus v, which is 20, and it's all over your 2 times your 11 And then what else? Plus 64.4 times G, which is our grade. It's key to note that our grade is 8%, but in decimal form, that is 0.08. All over, and this is in parentheses. Okay, so now it's just time to solve. And once you do solve all of that, you should get y is equal to 3.23 seconds. And so that is, let's see. Okay, so number 1 says, what is the RMEV? That's the crash rate per million entering vehicles at an intersection given the data. The number of crashes in a single year is 3, and the average daily traffic is 3,000 cars. Okay, so I always start by seeing what is given. Okay, so the number of crashes in a single year. Just highlight this stuff in green. This is good information for us. And the average daily traffic. Those are the two things that are given. All right. What are we trying to find? We're trying to find the crash rate per million, or the RMEV. And so are there any formulas needed for this? The answer to that is I don't know what RMEV is, and I'm just going to do a search because I think that will get me close. RMEV. All right. So now it's just a matter of looking at what they give us, right? It's at an intersection. I think that's important to note, because they give us a crash rate at intersections, and they give us crash rates for roadway segments. So this is at an intersection. Okay, so the variables that we need is A and V. So do we have A? A is the number of crashes in a single year at the location. So we have A, which equals 3. Okay, information is given. This is why we write this stuff out. All right, so what is V? V is equal to, V is equal to ADT times 365. Do we have ADT? Because I don't know what V is, so I don't have V, but do we have ADT? Well, ADT is the average daily traffic entering the intersection. Average daily traffic that we have is 3,000 cars. So we do, in fact, have ADT. So now we can solve for V. Right. All right. So V is equal to 3,000 times 365. All right. So what does our V end up totaling to? So for V, we get 1095 and 000. All right, so now we have V, we have A, and we can solve for our crash rate per million, our RMEV. So RMEV is equal to A times 1 million all over V, and we'll just substitute from there. 3 times 1 million all over V, which is 100, or not 100, but and for your RMEV, you should get 2.74 RA. I hope that you're enjoying this video. I just wanted to drop in and say, if you're looking to pass your Civil FE exam within the next 90 days, then you definitely want to check out the course that I've created. The video that you're currently watching gives you just a glimpse of what is in the course, and I have made it test taker proof. And what that means is no matter if you've been out of school for a while or you just have trouble with some of the engineering concepts, if you study this material that is in the course, it will help you to pass within the next 90 days. There are also full practice exams. Yes, 110 question practice exams, along with review guides and study schedule templates to help you pass. And these are resources that I have created for you. So if you want to check out any of those, just head down in the description box below and check them out now. Now, to stay up to date on any new videos that I drop, whether it is more practice problems like in this video, or if you want advice and some extra tips to help you pass your Civil FE exam, you're gonna wanna make sure that you hit that subscribe button, turn on those bell notifications so that you know exactly when I post. And if you wanna check out the next video, you can here.